Nowadays, buildings are responsible for 40% of energy consumption and 36% of carbon dioxide emissions in the EU. In order to drastically reduce these numbers, in 2010 the European Commission established that all new buildings must be nearly zero energy buildings by the year 2020. In this context, the European research project NEED4B was born. People from 5 cities of Europe, including architects, engineers, researchers and developers, came together to demonstrate how to design, construct and operate very low-energy buildings.
We have created 5 demo buildings with a very low energy consumption. To achieve this, we have integrated different energy-efficient and cost-effective technologies. We have tested and selected the best solutions for each of the buildings, keeping a holistic approach. This is, we have combined different energy-saving features considering all types of energy uses, and we have involved stakeholders in the process since the very beginning, keeping a building life cycle perspective. All elements and systems contribute to a better energy efficiency and sustainability through integrated design and planning.
The NEED4B team used BIM tools, LCA and LCC methodologies, besides computing simulations. The buildings were constructed between 2014 and 2015. Monitoring and control systems were installed in the buildings for registering several variables, for providing optimization for the building performance during their lifespan.
After 2 years of operation and building monitoring, we have proved that the annual energy consumption in all the buildings is lower than 60 kilowatt-hours per square meter, which matches initial predictions. This is a success for the project, indeed, although the true success will rely on the replication of NEED4B concept. For this reason, we have created a methodology that puts together our findings and provides recommendations to the different stakeholders of a project on how to create profitable buildings with very low energy consumption.
The variety of typologies and uses of these buildings, as well as their location in different climatic zones, makes the results of the project broadly applicable across Europe. On the one hand, the project has tested energy-saving technologies for family houses situated in colder climates. One prototype is the Stambruges house, located in Belgium, with 307 square metre gross floor area. It is built as a prefabricated wooden family house. Stambruges' total primary energy consumption is 28 kilowatt-hour per square metre per year, and it has 3,860 gram carbon dioxide per square metre carbon dioxide emission rate. Moving up a little to the north, there are 2 more demo sites, built as 2 prefabricated wooden framed villas. One is the Volksningsvillen, located in Boras, which has 217 square metre gross floor area and is used as a full-scale test laboratory for energy-efficient technologies. It is managed with artificial user behaviour loads. The house's total primary energy consumption is 31 kilowatt-hour per square metre per year, and it has 1,200 gram carbon dioxide per square metre carbon dioxide emission rate. The second house of the same kind is located in a residential area in Varberg, hosting a family of 5 members. The Varberg house total primary energy consumption is 52 kilowatt-hour per square metre per year, and it has 2,020 gram carbon dioxide per square metre carbon dioxide emission rate. In addition to residential buildings, NEED4B also provided energy-efficient solutions for tertiary buildings in hot climates, where reducing cooling demand is one of the main concerns. This is the case of the pilot, situated in the south of Italy. The KAFA building, located in Lecce, has 5,214 square metre gross floor area. It is built for office and commercial activities. KAFA's total primary energy consumption is 41 kilowatt-hour per square metre per year, and it has 8,240 gram carbon dioxide per square metre carbon dioxide emission rate. Another building exposed to hot summers and cold winters is the Schola building. Located in Istanbul, it has 17,756 square metre gross floor area and is built as a single academic building for faculty within the campus of university. Schola's total primary energy consumption is 50 kilowatt-hour per square metre per year, and it has 5,170 gram carbon dioxide per square metre carbon dioxide emission rate. Some of Schola's featured solutions are PV panels, earth tubes, and sun breakers designed for each facade.
We expected to show these buildings to be very successful so that they can be replicated, they can be used by more architects and engineers at different parts of Europe. Overall, comfort and energy efficiency will allow us to come out with the new generation of buildings where we will be more in harmony with nature, and we expect that our carbon footprint will be reduced in the construction of these buildings based on the integrated engineering and architecture principles.
The different demo sites experience different techniques for monitoring and data collection. After a certain number of surveys, occupants of each demo site have pointed out their satisfaction in general. On average, a primary energy reduction of 74% has been achieved, compared with a reference building of the same age. Annually, primary energy savings equivalent to 500 LED light bulbs over 160 years. Annually, carbon dioxide emission savings equivalent to more than 76 trips around the world in a new 2016 car. 363,489 kilogram carbon dioxide. NEED4B demo sites are open and ready to host visitors and spread the experience. Together with NEED4B, 3 other European projects with a shared goal came up with demo buildings in other locations in Europe. All of them best practice examples to inspire the buildings of the future and contribute to large-scale market deployment of zero-energy buildings before 2020.